Okay, so we've discussed ionic bonding, ionic formulas, ionic nomenclature. Now we're going to move on to the second type of bonding that we're going to talk about, and that is covalent bonding. And with a covalent bond, it's going to be between two nonmetals, and it's going to be formed by atoms sharing electrons. And so these orbitals are going to overlap, and those electrons in between are going to be the shared electrons, and that's going to be our bond. Molecular compounds are not very water soluble, but typically it's going to depend on their polarity. So think oils. Oils are molecular compounds. They are not water soluble at all. They generally have a very low melting and boiling point. Again, think oils, butter, things like that. They're held together by intermolecular forces. So like an interstate, these molecular forces run between molecules. Interstate runs between, it's a highway running between states. So an intermolecular force is going to be a force between two molecules holding those molecules together. Molecular compounds can form individual molecules that are large enough to see with your naked eye. So nylon is one really long-chained molecule. Occasionally, molecular compounds will form crystals, and these are very strong crystals. And the strongest crystal known to man is a molecular crystal, and that is a diamond. A single covalent bond is going to form when two electrons are shared by two atoms. So the first thing you're going to do is draw your Lewis dot structure for all of the atoms involved. You're going to connect your free, those are the ones by themselves, not already paired up with another electron. Connect your free electron between your atoms, and then redraw your structure neatly so that you have one bond coming off of each side at this point. So let's look at H2. And H2 has two hydrogens in it, so you're going to have to draw two hydrogens. And each hydrogen has one valence electron. So now you're going to connect your free valence electrons. And that connection are the two shared electrons. So when you redraw it neatly, H2 is going to look like that. If we have F2, you're going to have two fluorines. Each fluorine has 7 valence electrons. 1, 2, 3, 4, 5, 6, 7. 1, 2, 3, 4, 5, 6, 7. Connect your two free valence electrons. And so we have one line going between each fluorine. And you're going to rotate these guys to the outside here, like that. So each of those are a single covalent bond. Water, you have two hydrogen and an oxygen which has 6. So oxygen has those two free spaces that each hydrogen can attach to. So when you redraw it neatly, we're going to put the one who has the most free valence electrons in the middle. That's going to be oxygen because it has one free one here, one free one here. That's two free valence electrons. Each hydrogen only has one. So you put oxygen in the middle, keep its unshared pairs on there, and then you have a single line going to the first hydrogen, single line going to the second hydrogen. Okay, let's look at NH3, which is ammonia. And you do need to know that this is the common name for NH3. So nitrogen has 5 valence electrons. We have 3 hydrogens. Each one has 1 valence electron. So nitrogen has these 3 free, so we can pair up one with each hydrogen. So we're going to put nitrogen in the middle because it has the most free valence electrons. Keep its lone pair on there. And then you have 1, 2, 3 hydrogens, each one attached with a single line. Okay, CH4, we have a carbon which has 4 valence electrons, and then we have 4 hydrogen, like that. Each one has 1. So each one of these free, oh, I missed a hydrogen. Oopsie. There we go. Each one can go to one of these hydrogen. And since carbon has the most free valence electrons, we're going to put carbon in the middle. And so coming off of each side, you have one bond between carbon and each hydrogen. So sometimes you can form a double or a triple covalent bond, which means that atoms are going to share more than one pair of electrons. So a double bond is going to share 2 pair, and it's going to look like this between atoms. And a triple bond is going to share 3 pair, and it's going to look like this between the atoms. And the goal is to attain its octet. So if we have oxygen gas, which is O2, means we have 2 oxygen. Each one has 6 valence electrons. Each one has 2 free valence electrons. So these guys can pair up and these guys can pair up, which means that when you rewrite it neatly, okay, remember we're going to shift these guys over here to the outside. We have 2 lines connecting our 2 oxygens, and that is a double bond. And then these lone pair are going to shift to the outside here. Nitrogen gas is N2. So each nitrogen has 5 valence electrons, gives each one 3 free. So when we redraw it neatly, these nitrogens, we're going to shift their shared pairs to the outside there. There are 3 lines between those 2 nitrogens, and that is a triple bond. There's 1 triple bond, 3 shared pairs of electrons. Okay, so remember your diatomic molecules: hydrogen, nitrogen, oxygen, fluorine, chlorine, bromine, and iodine. Most of these are going to be single covalent bonds. All of these guys and hydrogen are single. Nitrogen is going to be a triple, and oxygen is going to be a double. So when they're paired up together, hydrogen, fluorine, chlorine, bromine, and iodine are all going to form a single bond. Nitrogen gas is going to have a triple bond, and oxygen gas is going to have a double bond.